Okay, so as I said, we will be looking at the test we're going to work through the memo of test 1 for computer programming. Okay, it's there's quite a lot of information, but I think I'm going to look at the important aspects. So this first couple of questions I'm going to go through quite easily. Can everybody see the board, the screen at the back there? Not okay. Let's see. What about now? That should be okay, right? All right. Because this is a review lecture for everybody, I'm going to go through it in English. But if you have trouble with that, you're welcome to let me know afterwards, and we can, for the Afrikaans people, okay? All right, so first question. Computer consists of 6 logical units. Name examples of 2 types of secondary storage. Well, that's just a memory stick and a portable hard drive would be examples of that. Now, this second question is an important one. This essentially you should have an idea about the whole process of the computer, about what the compiler does. We end up with a lot of C files and a lot of 8 files. The question is, please identify phases 1, which is this round circle, and phases 2, this round circle over here. So phase 1, what is essentially adding all these, changing all these C programs into object files or into libraries? That's the preprocessor and also the compiler. Then, now, what process in number 2 takes all of these object files and libraries and converts it into a single executable? Well, that's the linker. Okay, and all of this forms part of the compiler. All right. Question 2. Write a single statement in C that would be required to gain access to the standard C library that contains the scanf function. And that's the hash include standard io.h that you guys have been included in your program so far. Okay, so very important to take note here is these little brackets, the way that we identify the brackets over there. But as I said, if you guys have attended the practicals, you should be able to do this quite easily. All right, now we start looking at a little bit of code. The code below, so the code in this block over here, defines 2 variables. Those variables are x, y, both of them are integers, and you need to write one printf statement. So these boxes shows you a printf statement to go here with an arrow that would display the 2 variables and then the decimal number sum of the 2 variables on the screen. Okay, so the output of the screen must display as follows. So x, so the sum of first variable and 2 is, note there is a floating point summation of the 2. So question is, what goes in here? The answer is this one printf statement, the sum of %d, because it's an integer, and %d, another integer, is percentage. To get this decimal output and formatting, we use the .2f format specifier. Okay? This is x, y, and x plus y. And this will format this sum into the decimal format specifier over here. Okay. Next up. Okay, write 4 lines of C code that prompts the user to enter 2 variables, x and y, that are used in the previous question. Okay, so, well, you can do that using a combination of printfs and scanfs. So printf, enter the variable x. This is the expected output. And then you use a scanf, %d, because x is an integer, and remember to add the address of x over here, because I think now you guys have been starting on with pointers and things like that. So statements like this should be familiar to you. So in order for the scanf to work, you have to use the ampersand over here. And then second part, exactly the same, printf into the variable y, scanf into the variable y. Okay, now, okay. Oh, okay, it looks like you're reading this into a new line over here, right?
Yeah, the very first line looks like there's a space.
Oh, there.
The line starts, yeah.
Yeah, they would, I think they would explicitly tell you there is a new line over here using an arrow like this. Because if I'm going to jump ahead now, if we jump ahead, then there are, like for example here, there's an arrow that says single space or a double space or so on. So if we expect you to add a new line as part of the output, they'd explicitly tell you that. Okay. All right, so now structured programming. Write the code. So this, we give you a flow diagram over here that contains a for loop. So they say it's a for loop. So that should already give you a hint that your code is going to contain that. The variable num and others, so all these variables num and total and x, all those things have already been declared. You don't have to do that. Use assignments and increments or decrement operators where applicable, and give only the section of code represented by the diagram. So assume all the variables to be integers. All right, so because the question tells me it's been defined, I'm not going to bother with defining them using ints. I'm just going to use them. So first block is this one over here. We need to initialize total equals 1. So there, that line directly translates into this over here. Maximum is equal to num plus 1. Maximum is equal to num plus 1 directly over here. Okay, and now this part, my for loop starts. So the trick would be to identify that x is my loop counter. X equals 2 is done in the for statement. So there's my for statement, x equal 2. That's that line over here. When are we going to, what's my loop condition? Well, x has to be smaller than max. So I test x smaller than max, and then x is incremented. X is equal to x plus 1. So that's my loop iterative count over here. What happens inside the loop? Well, that's that block over here. Total is equal to total times x. And that's it. Okay. This part is a rather long question that I think some of you guys probably spent quite a bit of time on. And the way in which to, I think the tricky part with this question was to, after using the first refinement, there's quite a few statements that can be used to do this. The trick is to get those amount of statements down to 12. So what I would do is, after I first read this, I said, okay, given the high-level description, so this is the high-level description, I'm going to read that. I need to select only 12 from this list. What am I going to do? I'm going to initialize my variables. Okay, so I need to determine, well, okay, so the purpose of this exercise is to determine the class average of a test. Right, so what we're going to do is we're going to input quite a number of averages from students. Something to note there that it tells you, it doesn't tell you we have exactly 20 students in the class, or 15, or 50. It just says a class. So we expect, how are we going to know when to terminate our condition? Okay, because we need to read all these student grades in. But because we didn't specify a fixed amount, you need to know that, okay, this is some form of a sentinel. Remember that when we used iterative approaches, for loops, while loops, do loops, those type of things. We said that if there's two flavors of it, counter-controlled and sentinel-controlled. So here is a sentinel control, okay? So obviously if I want to calculate the average, I'm going to add all these numbers to a total, and then afterwards I'm going to divide the total by the number that I've actually read. So I need to keep track of how many I'm reading as well. How many grades am I reading also? And then I just have to print it out. So this is my big list. Again, what I said is, okay, I have in my head now, forget about all those things. How would I write it? Okay, I would have a program that initializes a total variable, because I'm going to have to keep track of the total that I'm going to divide by the number of students. And then I'm going to use some form of a while with a terminating condition that the user can set, okay, some arbitrary sentinel. And I'm going to keep on adding values to that total until that sentinel condition is reached. Afterwards, I'm just going to divide the total by the number of students that I've read, for which the grades I've read. Okay? So you can go now through all of these and see if something is you need to go and say, okay, my first refinement. So initialize my variables. Well, I said I've got a total. Okay, there's a total. Set the total to 0. The grade, no, I'm going to read unique grades each time for a student, so I need to set it to 0. But I'm going to have to use a counter, so I'm going to need to set my counter to 0. And then I'm going to have to read the first grade. I'm not going to read the second grade, third grade, and so on. I'm going to use a while for that. So let's look for a while. Here's my while statements. While the counter is less than the Sentinel, while the user has not input the Sentinel. Okay, that sounds like something I can use because that quantifies the user, for example, pressing -1 or pressing C or Z or whatever. But just that would work. Then I need to start adding my grades to the counter. Okay, but now in order to avoid confusion, this is what the pseudocode is that I would select. Probably in the beginning it would be difficult to, after your first iteration of answering this question, get to exactly those 12 steps. So what I will do is I would start off with a first draft and use the statements that I think are necessary, and then as a second part, see where you can simplify your code even a little bit more. Okay, so let's just run through the answer. We, as I said, we're going to need some form of a total to add all the grades together. And then we need to count how many students there are. So we need some form of a counter that we also have to set to 0. And then obviously we need to read the first grade. Then in a while loop, we're going to continue while the user, so the lecturer, hasn't entered the Sentinel. The Sentinel is now, for example, a -1, and then the thing stops. Okay? We're going to add the grade into the total. Then we're going to increment our grade counter, and we're going to input the next grade. So we're going to keep on reading the grades. And then I say, okay, that's now enough grades, so this while ends. What then? If the counter is not equal to 0, okay, so why not equal to 0? Because we can't divide by 0. Because the average would be the total divided by the counter, and then we just print it out. Else, if the counter is 0, that means that no grades have been read. Then we just output that. Okay, so not something that I think a lot of people would see first off, but probably the best way to go about answering this type of questions is look at the overall program, think what you would do yourself, and start writing it using everything that you can, and then after that, try to reduce this or to simplify it a bit and see if you can't combine some of the input statements and so on. Okay, this is simple. Draw a flow diagram for the if-else and do-while control statements. So the if-else looks like this. So this is just an example. So we start off with a circular little block over there, circle, that's where the begin is, and that's the end statement. This is my if, this diamond. My condition, for example, if grade is greater or equal to 50. If it's false, print failed. If it's true, print passed. And we terminate in this end little circle over here. The do-while, trick with difference between a do-while and a while is the do would start here, the beginning statement, then do the actions, then test the condition. The while statement is the other way around. If the condition is true, you continue again. If it's false, the do-while statement just exits. Okay, this one is pretty interesting, this question 4. So it contains a double for loop, and I remember from the lecture notes, you had that star problem. You guys remember that? And also, I think in the practical also, we had to print the stars on the different lines. So this is just a variation on that question. Okay, so what you would do is you would say, okay, I've got 2 loops over here. I'm going to print out either spaces or stars, and it's going to contain a new line. And this for loop. Let's look at the first part. So what does this for loop do? This n is equal to 0, n smaller than 5, n plus plus. And then the next one goes over to a for loop m equal to 0, m less than 5, m plus plus. So this one, we would handle the first row, and then you'd iterate over the columns. And then if n is equal to 1, you move over to the second row, and then m controls the columns again. Okay, so by considering now the first one over here, we need to say, which one of these is the correct answer going to be? Okay, so firstly, what I would do is I would start off by saying, okay, what happens if n is equal to 0? So if n is equal to 0, m is equal to 0 also, and then which part of this if is going to be valid? The second part, this part over here, because m is equal to 0, and 0 is not equal to 2, 0 is not equal to 3, and 0 is not equal to 3 also. So that, it's not going to print out a star, it's going to print out a space. For the first star, right in the top left-hand corner, a space. Okay, so all these options that contain stars in the top left-hand corner, that cannot be valid answers. Okay, so I would then remove all those from my answer list. And then what we end up with is, so all these that contains a star over there cannot be, because the first iteration of this loop is going to print out a space. So you can reduce, you can narrow down your answer and identify only those options that can work. And these are essentially this one, this one, this one, not that one. Okay, and this one over here. So significantly reduce the complexity. Okay, then I would go over and I would say, if n is equal to 1, what's then going to, if m is equal to 1, because remember this inside loop is going to continue, n is going to remain 0 first time, we're going to iterate over all the various columns. So we're going to see if we can print out an entire row first. So then I would say m is equal to 1, what would this value then be? Am I going to print out a star? Am I going to print out a space? Okay, so if n is equal to 0, this means, and this is equal to 1, 1 is not equal to 2, we're going to print out another space over here. So you can go back to your possible selection of answers, and you can see, okay, so again, these are possible values. What happens now with the third one? So if m is equal to 2, okay, and n is equal to 0, what's going to happen then? Then you say, oh, okay, well, n is equal to 0, so that condition is a 2. M is equal to 2, 2 is equal to 2. Okay, we're going to print out a star. So then you can already then identify, well, that one is out of the equation over here. What remains is this one, and this one. So essentially, then you just go over to the third column. Okay, so that's the only way to answer this question is to substitute the values for n is equal to 0. So just for interest's sake, n starts off at 0. What would be the last value for n? 4. Okay? So if the last value for n is 4, how many stars, how many rows are we going to loop over? From 0 to 4, that means 5 rows. Yeah, so that outer loop, this outer loop n, controls the number of rows over here, and the inner loop, this one, controls the number of columns over here. So the best way we should answer that would be to write a grid and say, what happens if m and n is equal to, start from 0, work all the way up to 4, this is a star or space, and then you go to this answer, this part of the answer, and you eliminate the options that it can't be. Okay. Same with this over here, this answer over here. I would also follow exactly the same approach. Okay, now this one, in each of the cases shown below, so this is the case below, let's start off with this one. write a segment of C code that uses one for loop with one included if statement to display the given output on the screen. The sequence is important. So obviously you need to identify what is my sequence over here. So write down all the numbers, 17, 25, 33, 41, 49. What is the difference between those things? So I think if you guys look through your engineering mathematics, again, you have two types of sequences, series and sequences. I think this is called an arithmetic sequence, if I'm not mistaken. But in any case, you can identify very easily that the difference between these two numbers stay constant. So 25 minus 17 is 8, 33 minus 25 is 8, 41 minus 30, each one, difference between the two numbers is 8. And I know that we specified use a for loop, but there's also 1, 2, 3, 4, 5. So there's 5 numbers. I know where they start off. They start off with 17 and they end with 49. So I can write a for statement that looks like this. I'm going to say counter starts at 17, and also counter, it needs to continue while the counter is less than or equal to 49. So this will let my counter go from the start number 17 to the end number 49, and each time I'm going to increment it by 8. Well, that's the difference between the two. So what I'm going to do now is I'm going to print it out, but the tricky one is, what are we going to do here when counter is 33? We need to go over to this line over here. Okay. I think there might be a mistake over here. If counter is equal to, oh yeah, if count, no, it's right, it's correct. So in each case, we print a new line, except when counter is equal to 25, this number over here, then we don't print a new line. Okay, so that'll just output the digits like that. Okay. This is a little bit more of an interesting sequence. 5, 0, minus 5, minus 10, minus 15. Again, a series. And what can we identify? What's the pattern over there? Well, the pattern is that you just deduct 5 from each of the iterations. Okay? So again, we can use a for loop. We start off with 5. We end at minus 40. So counter is 5. Counter greater or equal to minus 40. And we say counter is equal to counter minus 5. So we subtract it. Now we are going to print it out. We're going to printf counter. Well, there's a couple of format specifiers. We need to say that if you can see over here, there's about 4 spaces that you can use. %4d, print out the value of counter. And on these numbers, minus 15 and minus 30, you have to go over to a new line. So you need to see what is the significance of 15 and 30. What do they share? What pattern do they share? And that is they can both be divided by 15. So 15 divided by 15 is 1, 30 divided by 15 is 2. And the way in which to see that is by using the modulus operator. So remember, that will give you the remainder. So 15 modulus 15 is 0, because nothing remains, right? 30 modulus 15 is 2 modulus 0. So again, 0. So when you reach any one of these values, then you print out a new line. Okay, over here. What would the following C program do? So what we have, so it's obviously again a bit of a pattern, but so the best would be to say, okay, let's just follow. So you start off with counter is equal to 2, and then you say counter is equal to counter plus 2, so and you do this while counter is smaller than 11. So 2, 4, 6, 8, and 10. 1, 2, 3, 4, 5. 5 times it's going to iterate. So that would be the first step, is just identify how many times is your counter going to loop. So 5 times. That's my loop condition. Sorry. Okay? So the first thing is C is equal to A times B. Well, what is it we start off with? A is equal to 0, B is equal to 1, so C would be 0. So we're going to kick off this part of the code because C is 0. And that's just going to print F the value 0. But then we set the value of B is equal to 2 and A is equal to 1. Then we go back to this part. So A times B is equal to 2. Is it? Yeah, 2. We set the value of C. C is not equal to C. Oh, sorry. C is not equal to 0. Printf percentage %d A. And the value, I don't know why this thing is constantly doing this now. Print out the value of A. A is 1 over here. And we print out a 1 there. And then we just continue. Okay, so C is not going to be 0 again. It's going to remain in this part of the loop. You just have to, now, trick was, firstly identify how many times this loop is iterating. So I know that my condition is it has to be less than 11. I add 2 every time, start at 2. So that's 2, 4, 6, 8, and 10. Because after that it's 12, and then this thing fails, so it's 5 times. So for each of the 5 times, I'm going to do each one of these. It's pretty simple. You guys should be able to, just by writing out tracking what A and B is, write out that sequence. Okay, recursion. So remember when you went through your recursion slides that we said any for loop can also, or any recursion can also be implemented using a for loop. And this is exactly the for loop that we're identifying here. So this function determines the factorial of a number. So for example, the factorial of 3 would be 3 times 2 times 1. Or the factorial of 2 is 2 times 1. Factorial of 1 is just 1. And I think the factorial of 0 is also undefined or 1 something. But any factorial can be broken down into the number times a smaller part of the function. Okay, so that is what recursion is it breaks it down into smaller bits of the same question, okay, until you get to some simple base case. So essentially, if you look at your function over here, this one declares an integer I because it's used in the loop iteration, but you're not going to use that when you use factorial. Sorry. We keep track of the calculation, that is our answer. If calc is equal to 1, okay, then if the input, what I give my function is equal to 0, then as I said, factorial of 0 is equal to 1. Otherwise, I'm asking the function to calculate the factorial of the particular number, and then I just iterate until I reach, for example, 3. So I is equal to from 1 to 3. Then I say that the answer is just 3 times 2 times 1 using this for loop. So now, if I have to break this down into using recursion, then I would focus on this part over here, because as we said, we can simplify any for loop. We can simplify recursion or exhibit recursion using any for loop, and this would be that for loop. That's the only for loop also in this function. Again, I still, however, have to return for my function in some way. So I return my calculation, and I do define my base case over here. That is when my input is less than or equal to 0. But what am I going to do now for my recursive step? I'm going to say that my calculation is equal to my input times the same function, factorial, right? Recursively call it, but using a simpler version of the input. So this would be input minus 1. So every time this function is called, it'll reduce until it gets the value of 0, and then it'll start returning. Best way to understand this, if you don't understand it yet, is to look through those lecture notes of recursion, implement it, and use printf statements in the code to see when the function is returning. Okay. All right, this is also a pretty straightforward question. We have this program is shown below that is used to sum two values. So we have these values, integers, int x and int y, and we need to call a function. So if you can remember your layout of your programs, above the main is your function prototypes. Then you have the main with all the operations. Then below it, you have your function definitions, where the function is actually declared and implemented. Okay, so if you look down here at step 6, 7, and 8, 9, and 10, then you see my function is called f. So I need to fill in the missing parts. All right, so let's say I need to, okay, so I have to, what is my function doing? The function is summing two values, x and y, or a and x and whatever, and then it's just returning that. So if I look at my function over here, step 10 should return the sum of those two values. Okay, so I would start at this part with answering the question. I would say, all right, return, well, this sum equals float g plus h. That calculates my sum of the two values, and I'm going to return it. So 10 becomes sum. So that is a sum. Okay, when I see, all right, well, if that is the sum, and sum is being, this g plus h, this over here is being cast into a float, then what is the type of my return value? That should also be a float, right? So that's the answer of 9. Okay, 6, that specifies the type of my return, as I said, that's a float. Well, this variable 9, this space 9 over here, this variable sum, has to be a float because we're casting the values here into a float. But what is my, if I would like to now, I want to call it using, I want to call this function using input arguments 7 and 8, for example, g and h. What would 7 and 8 be? So 7 and 8 would be two integers, okay, int x and int y, for example, or int g, oh, no, it will be g and h because I use g and h over here in the function, so I have to declare them over here, and they will be of type integers because I want to call my function using x and y over here is integers. All right, so I immediately know that that's int g and int h, or other way around. Then I can go back to this part over here. If I have to find my function over here, I can clearly see that what 1 should be. 1 should be, let's just see, I think I've got it over here. Float f int g int h. Okay, now all that remains is 2, 3, 4, and 5. So in 2, I'm just calling f, and I'm calling it, if you read the comment over here, function call to add x and y, so I'm giving it x and y, so that's why it's got f, x, y. It's cast into an int because the return value a and b is specified over here as int. Okay, same thing. We call the function over here to add a and x, so it's f, a, x. And the last part is this 4 and 5, so the sum of a and b is, this is a format specifier that we need to show, percentage f, and in 5 I need to just calculate the sum of a and b. That's just the function call f, a, and b. Okay, so not really very tricky. The key would just be to start at the correct end, and the correct end is not necessarily 1. I would have started here at this part and work my way up. Okay, so what would the following program display? This is also something that tests a little bit your pre and post increment operator knowledge. So the key here is to say when is it being pre-incremented and when is it being post-incremented? Okay, so firstly, we have a for loop over here. So let's look, we have global variables, some global variables, and a function called something. And my function something is defined at the bottom over here. So, very importantly, there's two types of variables in this something. One is a static variable called int x, and it's initialized to start at 5. The question is, what does a static variable, what does a static declaration do within a function? And the thing is, what static does is it causes that value, that variable, to retain its value between function calls. The other variable, int y, that's also initialized to 4, but that will always retain that will lose its value between function calls. So if it initializes again, if it's called again, it'll initialize to 4 again over here. As opposed to this static x, where's x used? I see, okay, there's x is post incremented. So x is going to be incremented. Next time it's called, this value of x would have been 1 more. So it'll be 5. It'll be 5, then 6, then 7, and so on. So how many times is this going to iterate? I is equal to 0, I less than 3, I plus plus, so 0, 1, and 2, so 3 times. Okay, so we know that my answer is going to contain 3 numbers written under each other because of the new line. So we just have to figure out now what those 3 numbers are. So the first time we call this, do something, x is equal to 5. Let's increment it, x plus plus, so x becomes 6. Now, this is the important part. This is what we're returning, y plus plus times x. This is a post increment operator. This means that the y's value will first be used in the multiplication over here, and that value is what's going to be returned, and after it, y is going to be incremented. So y becomes, during this operation, y will always be equal to 4. Because only after the multiplication does it get incremented, but the return value is set to that particular instance, when y is still 4. So just to make sure you understand that fully, review the parts on pre and post multiplication and write a small program to just test those. Change this value, this plus plus, change that, this y plus plus, change this one to plus plus y. Okay, so my x at this point, first time this function is called, will be equal to 6. So 6 times 4 is 24. That's my first number. Remember, x is now static, so that means x will be 6 the next time it's called. Y will still be 4. So 6 times, 6, but we increment it, so that's 7 times 4, 28. And then the last time, x becomes 8. So 8 times 4 is 32. So that's the sequence that you guys would get over here. So critical here, just understanding exactly what the difference is between pre and post, difference between statically declared and not statically declared local variables. Okay, arrays. So what we have is we need to declare an array with the name class marks that can store marks for 10 students. Okay, so we know there's 10 values in this array as decimal numbers, and this array should be initialized according to these values over here. All right, so that's the first part of the question. Let's do that first. So we're going to use float. The array's name is class marks. You could have also used double class marks, and in square brackets, the number 10, because we know there's 10 values. It's also said to you in the question, is equal to the curly brackets with all these numbers that we give you. So that's how you initialize the array. Then, second part of the question is, complete the code given below. So I think what you guys probably have is you only have this, add this part, and maybe the keyword 4 with an empty brackets over here, but you had to complete this, this yellow parts over here. So essentially what that part does is it calculates the class average and it displays it on the screen. So we're going to loop. We know there's 10 numbers, so from 0 to less than 10. Why not equal to 10? Because then essentially you would access an 11th variable of the, or 11th index of the array, which is not valid because you only declare it to be of size 10, and array indexing in C starts off at 0. So that's why we start off at 0 and continue till we are less than 10. This will give you 10 indices that we're accessing, and we're just incrementing our index. Then all we're doing is we're keeping track, we're adding these class marks to the total, similar to what we did in the previous, or our idea was in the previous example. And then it just prints out, calculates the average, total divided by 10, print it out. Okay, string handling. So a very quick question on string handling is, the name of the function is getStringLength. That's also given to you over here. And what you had to do is calculate the length of that string. So firstly, well, a character array is consists of characters and also includes this null terminating character. And that was the hint, and that should have told you guys, okay, now I know that that thing has to be there, and that's where my string stops, right? So the easiest would be to use a while, and you loop through the string while the character in that myString array is not equal to the terminating null character. Then if it's not equal, just increment your index, and you count the number of characters until you get to the null terminating character, and then it exits, and there you have your string length. And that's it. Okay, so do you guys have particular questions on any one of the, any particular questions on anything in the test? Okay, so yeah, that's it. I'll see you again next week at the review class, then we'll start looking at the theory again. I just want to stop.